At this point, we have learned several data structures in Python. One of the important things is lists. Basically, a list is to put items between a pair of square brackets. Now let's take a quick look at this question. It's easy to generate a list, right? Just to type in the numbers or strings or whatever objects you want to include in the list between square brackets. But sometimes you may want to quickly generate a large list. For example, let's say we want to get a list of 100 numbers, 1, square root 2, square root 3, square root 4, until square root 100. Right? If you want to manually type in every value, that's going to be very, very time consuming. We can quickly complete this task by using a simple loop. To do that, first of all, we need to import the math library to calculate square roots. Right? Then after I imported math, I'm gonna start to generate a list. Notice the pattern here, right? It's a square root of an integer from 1 to 100, right? So I'm gonna just write sqrt. Actually, it's math.sqrt, the square root function applied to the number I. Right? But for this number I want to have this number I take different values from 1 to 100. A quick way to do this is to say let I change between 1 and 100. We can use the range function, right, from 1 to 100. But in the range function, we have to use 101, right, because the ending value is not going to be included, which is a convention in Python. So let's press Shift Enter to see the results. Well, looks doing okay, right? The first is 1, the second square root 2, that's basically 1.41, and there are more values, but last one, square root 100, should be 10. So that's a useful technique, using a for loop to generate a relatively large list within a short period of time. And the next data structure we want to talk about is set. Like lists, a set include a collection of items, but this time there are some differences. One important difference is that, well, sets has no orders for the items in it. Right? It doesn't matter which item comes first, which item comes second. As long as you have the same collection of items, it's going to be the same set. Let's quickly create a set. This time we're going to do a set of strings. Let's say the name of the set are my favorite fruits, and we want to include a set of strings to represent the name of different types of fruits. Let's say banana, apple, orange. Let's do another apple, right? And let's see what happens. After I define this set using this assignment statement, let's also type in the name of the set as the last line of the cell. And this will force Jupyter to display the content of this variable, my favorite fruits, after we have defined it. As we can see, even though we have included 4 different strings, it turns out there are only 3 items. That's because there are 2 apples, right? Apple, this word apple appeared twice. So a set does not allow any duplicated values, right? If you have apple twice in the set, one of them is removed. And also, the content of my favorite fruits, this set, starts with apple, right? Which is different from the list of names, fruit names I give it. This shows that, well, the order I give the set doesn't matter, right? As long as you have this many units, this many items in a set, then it's the same set. Okay, that's the set. Several simple operations about set. We can check if we have more than one set. We can check, well, whether or not those two sets are the same set. If one is a superset, the other is a subset, right? So let's define another set called healthy fruits. This time, let's say we have apple, orange, banana. So we need to use the quotation marks to represent that they are strings. Maybe one more item. Let's say grape. Okay. So we define another set. By the way, to define set, we put items between a pair of curly brackets instead of square brackets. Square brackets are for lists. Curly brackets are for sets. Now, after I've defined the healthy fruits, let's try to see if the previous set, my favorite fruits, we use a method called the is subset. Right? That's a method that comes with any set. So this time I want to check if the previous set is a subset of this new set I will define, healthy fruits. And then run the cell. It says true, right? Because as we can see from the previous set, apple, banana, orange, and the healthy fruits includes apple, banana, orange, and grape. So there's one more item in the healthy fruit set than my favorite fruit set. So this is when we say my favorite fruits, that set is a subset. It's smaller than the new set, right? Or sometimes we say the healthy fruits is a superset. Okay, so the next data structure is called dictionary. A dictionary is very similar to a set, but instead of being a set of several items, a dictionary is a set of several key value pairs. So what do I mean by that? Let's take a look at one example. This time I want to define a dictionary. Let's say it's called a student. Okay, this is similar to a set. Let's use curly brackets. But every item in that set will be a key value pair. There's a key and a value. The first item, let's say the key is name. And then I'm going to use column to separate key and value for every item in this set of key value pairs. Name, let's say Jack. Okay. Let's say there's another key called student ID. And the value for Jack is 1001. One more pair. The key is, let's say, gender. The value is male. One more thing. Let's also create a key called courses. And the value this time is not just one single value. Instead, it can be a list, right? So let's say we have O712 and just another random course code that pops into my mind, B790. Okay, so that's how we define a dictionary. So if we check the type of this variable, a student, we're trying to define, and let's see how it looks like. It's a dictionary. And then we can also quickly verify the content of that dictionary, right? So there are 4 things in the dictionary, and every entry of this dictionary has a key and a value. Now, in order to access the value of the entries in a dictionary, what we can do is that we can call the name of the dictionary and then square brackets. Between the square brackets, we can use the key value. Let's say one of the key is name, right? As what we have just defined, and that will give me the corresponding value, right? The key name is corresponding to the value Jack for the specific dictionary we created. Another quick example, we can say a student. This time, let's look at the courses. Okay. Courses as the key value, and that will give us the corresponding value for courses. That's a list of 2 courses. Now, if you want to get the length of a dictionary, which simply means how many entries do we have in a dictionary, as what we have seen for lists, the same function len can be used. The length of a student dictionary is going to be 4, right? As we have just seen, there are 4 entries, each entry being a key value pair. It's also easy to change the value of any entry in a dictionary. So let's do that. First of all, we can do a student, let's say name. We know it was Jack, but if we want to change the name, let's say we want to also include a last name, Jack Sparrow, and then we can try to let Jupyter display the content of the dictionary after this assignment. Now the name is Jack Sparrow instead of just being Jack. After the assignment, we'll assign a new value to a certain key. We can also define a new entry for a dictionary. This time, let's say a student. Let's create some entry called initials. Pay attention here. The key initials did not exist before, right? We didn't have a key called initials. But what we can do is to assign a value to this key initials that did not exist. Right? Let's say initial would be Jack Sparrow or JS. And then by assigning a value to a key that did not exist, we actually created a new key value pair. So let's display the content of dictionary again. As we can see, now there's another key value pair appended to the end. Initials is the key and JS is the value. Sometimes it may be convenient to create a dictionary from 2 existing lists. So this time let's do this. Let's first define a list of cities. Let's say the cities are Toronto, a string to represent a city, right? Burlington and Hamilton. Another list, let's say we want to include the corresponding populations of those 3 cities in thousands, right? Toronto, maybe 2 million or 2,000,000. I'm going to use 2,000. Burlington, maybe 150,000, right? So let's do 150. Hamilton, that's 500,000, 500,000. And then run the cell. That will give me 2 lists. After I got 2 lists, what we can do is to use a command called zip. I will zip together the 2 lists, cities and populations, right? After I zip them together, I will convert the result of the zipping to a dictionary by using the name of the data structure, right? Dictionary dict. Now I will have a dictionary, like 3 key value pairs, keys being Toronto, Burlington, Hamilton, the values being 2150 and 500.